Hey everybody, welcome back to the channel. I'd say over a year ago we made this double start tap here on our YouTube channel, and that was a fun project. And ever since then I've been dreaming of making a double start split adjustable high-speed steel threading die to match something similar to this. My problem all this time has been I couldn't find any material big enough to make a threading die out of. Now, you can buy these high-speed steel blanks from Amazon and in a number of different places, and the small ones are pretty cheap. But as soon as you start getting into the bigger stuff, it becomes an awful lot harder to find and an awful lot more expensive. Well, I finally had a breakthrough. I found someone willing to donate this fairly massive piece of M2 tool steel. It's a drill bit that is no longer useful as a drill bit. And so this is going to become a number of different projects in the future. And right now, it's going to become a threading die that's going to come from right around here somewhere. Real quick disclaimer before we get into it, this is not a heat treating video. This is a grinding video. First thing I need to do is get rid of this fluted area of the drill bit. It's way too hard for me to cut in the bandsaw or to machine in the lathe. So what I need to do is determine where the transition between hard and soft is, and then I will make my cut airing towards the side of soft, because I really don't want to ruin my bandsaw blade. And the way I'm going to do that is pretty simple, pretty straightforward. I've got a file here. Typically files are about 62 Rockwell, which is about what a drill bit is as well. So I can just come along here. If it cuts, it's soft. If it doesn't cut, it's hard. This file is still cutting, still cutting. All this pickup is somewhat of an indication as well that this is softer up in this region. And now it's still cutting. It's getting harder though. I think to be safe and kind to my bandsaw blade, I think my cut's going to be right around here somewhere. And before I do that, I just want to double check that there's no hard spots down in the flute here, and there doesn't seem to be. So I'm going to set this up and cut this off in the bandsaw right about here, and that should be soft material all the way through. So fingers crossed that I'm cutting only through the annealed steel, and I'm not cutting any hardened steel because I really don't want to ruin this blade. That would be an expensive mistake. Let's see what happens. So far, so good. So that worked just fine. It cut all the way through, and I don't believe I did any damage at all to my blade. And we only have the soft annealed steel here. All the hard stuff has been left behind. Next step is to set this up in the lathe, but before I do, there's all this old crud really glued on here. I want to get all the surfaces where I'm clamping, gripping, and guiding this thing to be clean. So over to the wire wheel, I'm going to shine up the outside of this, and then we'll make our way to the lathe. This piece is sticking out way too far to do any machining on the end. I mean, I could center drill it, I suppose, but that'd be about it. And I have actual lathe work to do. So I'm going to use the steady rest on this. Now, before I get the steady rest out, my first step is to get it running zero at both ends. And so I'm going to do that off camera. When I have it running zero both ends, I'll bring you back in. I'll show you that. And then I think you're going to find the setup of the steady rest kind of interesting, maybe. So we'll show you that when we get back. I'm pretty happy with this. We're pretty darn close to zero there. And when I come down to the other end, pretty darn close to zero there too. I've got my steady rest in place now, and if you look super carefully up inside, you'll notice I don't have the little support bearings touching the workpiece yet. What I do have is a zero on my vertical axis and a zero set with a dial on my horizontal axis. And so I'm going to treat this a little bit like a four-jaw chuck. I want to bring all these into contact and get them touching firmly, but maintain both of those zeros. So I'm going to start by coming up on the bottom until I just touch, and I should see movement on both dials. And as soon as I see any movement at all, I'm going to stop. This dial should go minus, that dial should go plus. So there I can see them just starting to move. And now I'll bring this one up. Okay, just starting to touch there. Now when I bring this one down, I should be able to get those dials both back to their zeros. We're very close. And now I can do a little tweaking with these guys if I need to. And that's awful darn close. I'm going to call that good. I'm going to lock everything up. We are running very, very close to zero there. And I'm still zero on both dials. So that's going to work well for us. We're going to have adequate support. Those things are decently snug on there. That'll keep the chatter to a minimum, and everything's still running true. I've got some oil on my brass wear pads there on the steady. So I'm going to start by facing this thing down, get it running nice and true, and then this will be our finished face. Incidentally, we're using the high shear carbide tip turning tool that we made in another video. So I'll put the video of making this tool bit and the video of making the tap up at the end of this video, in case anyone's interested in seeing those. So I'm getting ready to turn down the OD here. I'm going to turn down enough for the part and about another 1/8 of an inch or so, and that'll leave me room to get my bandsaw blade in there to cut this blank off and carry on with the machining from there. I will be bringing the outside diameter down to its finished dimension during this setup. I've got my one face done, and I've got my outside diameter done, and I put a nice little chamfer on there. Now it's back to the bandsaw to cut this off. I'm ready to cut this blank off, and I'm clamping on a taper, which is normally like a terrible idea, but I've done some math. I have myself some shims, so I've got these extensions that I made so that I can hold things very close to the blade, and I know that this all in behind here would be clearance because of the taper, so I've got some shims, and what I did was I brought those in so that the front got tight at the same time the back got tight. And then I also have a shim the same thickness as these that I positioned underneath the same distance in. So this should be decently both horizontal and really well supported because it's gripped at both ends. So I'm hoping this won't move on me. I've had pretty good luck with this in the past, so let's see what happens. I am going to stay nice and close so that if something goes wrong, I can shut it down right away and hopefully save the part. Getting ready to face this down to the finished thickness. I'm going to center drill this, and I'm going to run my tap drill through there. I'll step up a couple sizes before I get to the finished size for my tap drill. And then we'll get into the scary part. The nominal drill for tap drill for 7/16, which is what I'm making here, is a W, which is 386 thou, and the closest I have is 390 thou, but I figure that's fine. That'll make it a little easier for my homemade tap to survive tapping this out. And that tiny couple thou of threads we're missing, it isn't going to matter. So this is the first step of the process where things could go terribly wrong, and that's mainly due to the point that we're taking my homemade tap now and we're running it through steel for the first time. After I made this, I ran it through aluminum, and that worked like a dream, but here's my first go on steel. So to up the odds of this working, what I've done is I've got my carriage here, my table is following along with the pitch of the tap. Now actually, this being a double start tap, I mean in 1 inch there are 20 teeth on here, but in one revolution it moves 2 teeth, so it moves at a rate of 10 threads per inch. So I've got my split nut engaged and I have my quick change gearbox set to cut 10 threads per inch. That way, as this thing advances forward, it won't be cocking on here. This will be driving along right beside it. So I've oiled the heck out of everything and we're gonna see what happens. Once I get in a couple turns, I'm going to stop and break the chip, and I don't really want to take it out and clean it off altogether, but I certainly will stop here and break the chip now. Oh, so far so good. I'm in enough turns now that it's as straight in there as it's going to get. I won't be able to have a whole lot of influence on its straightness from here on in. So just to give myself more feel over what's happening, I'm going to stop following with the tailstock and I'm going to just start tapping by hand. This is also going to allow me to break the chips more regularly and more easily. Does seem to be working. Tap's just starting to come out the other side, so I'd say we're over the hump. Real close to being able to call this a success. And there it is. One double start threaded hole. Well, there's our threads. You may notice I did not chamfer this. I did that intentionally because the area that's going to become our relieved lead-in, I don't want that area being interfered with by a chamfer, so I'm just leaving this like this for now. We'll add all those features later after it's hardened. I'm just finding the position now of the holes I need to put in here to create my tooth faces. I'm going to start by center drilling this, and then I'm going to work my way up in drill sizes, and when I start breaking through into the threaded area, I'm going to switch over to end cutting end mills, and I'm going to really go as small as steps as I can because this thing's not crazy rigid. I don't want to push my luck and ruin the whole thing, but that's where I'm at now. I'm getting to the part now where I'm going to break through the edge of this hole pretty soon and be in around my threaded area. So what I'm doing is I'm stepping up. This is a 1/4 inch hole, this is a 5/16 end mill. So I'm gonna go 5/16, 3/8, and then finish with a 7/16. I believe the end mill has less chance of going crazy and wandering off into that threaded area than the end mill does. So we're gonna see how that goes. Gonna go nice and easy, because again, not super solid. That's working decent, and it'll get even sturdier the farther I get into the hole, I believe. And for the money, this is my final size. I've got this out of the machine now. I've got it cleaned up. That all went pretty decent, I feel. Next step is I have to pop a couple holes in there. That's what it will be held into the die stock with. After that, it's off to some heat treating, of which I am no expert, but I think it's going to be pretty straightforward. From what I understand and from what I've experienced personally, it's a bright orange, glowing hot, and then quench it in oil, and then expose the shiny metal again, bring it up to a light straw brown color, quench it again, and then that will temper it. And then after that, I'm going to put the slit in it. No, after that, I'm going to put it in my camera leaving fixture, put the reliefed lead-in angles on it on both sides. And then finally, the last thing I'll do is slit it so that it's actually adjustable. We're all set for hardening now. I'll just point out off screen, I put these dimples in. That's what's going to drive it in the die stock. I also put a little spot there. That's where the center of my slit is going to be later. So for now, we're going to get this bright orange, and we're going to quench it in the oil. I am going to focus this heat to the thicker parts around the outside. I'm going to keep my flame right away from the teeth themselves. I don't want to risk melting those delicate little teeth. Now the side facing me is ripping hot, but I need to keep at this until that heat soaks through to the other side. I want the whole thing that bright orange all the way through. I can see that heat traveling now. It's working its way to the other side. It's made it into the teeth. Quenching in old motor oil. Might get a little flare up, but won't be any big deal. And in we go. Figure 8 motion for even cooling. So there it is, hardened. It's got a little scale on it there. What I'm going to do is I'm going to wire wheel the outside just to make it a little more consistent. And then these I'm going to put in the belt sander, bring them back to shiny metal. File here, and it's not even touching it. I don't know what hardness this is, but at this point it's harder than this file, definitely. After wire wheeling, you can see there's a fairly consistent, fairly decent finish on the outside of this. I'm just going to leave that just as it is, and I'm going to give these a lick now and shine them up. There it is after a little cleanup on the belt sander. We may get a little fancier with that after it's tempered. So it's been like literally hours. This is at the temperature that I thought we were shooting for, and it is still silver. Nothing has happened to it. That led me to doing a bit more research. I thought I had done ample research, but I got into it more, and I think I inadvertently was using temperatures for an altogether different type of steel. I'm not certain about what type of steel this is, but I would wager it's M2 or M42, almost definitely. So I'm going to call it for today. I don't think I actually got this hot enough to do anything to it. So rather than do any cooling of any kind, I'm just going to leave it in here to cool slowly. I don't think that'll hurt it. I can always test it with my file, get an idea where it's at. And worst case scenario, I could always anneal it and start over if I had to. But I think I've done nothing as far as tempering goes. I'm going to do a bunch more research, come back and hit that another day. It's getting late today, so I'm calling it for today. So next day, and I've done a ton more research, and I did in fact, I was using the wrong process for M2 or M42. Again, I'm not sure what this is, but whatever I was doing was wrong if this were M2 or M42, and I'm quite sure it's one or the other of those. So today I'm going to start over again, and the way I'm going to start over again is by annealing this, because I didn't transition from hardening to tempering properly for M2 or M42. So I'm bringing this right back to annealed state, and then once that anneals properly, then I'm going to harden it and temper it properly, hopefully, and we can carry on with this project. I'm going to heat this up fairly slowly, again focusing the heat on the thicker sections, and I will let it travel through to the thinner sections on its own. I don't think there's any cracks in there, and also I think if there were cracks in there, they'd be showing up now that it's getting up to that glowing orange temperature. I think I'm safe. Okay, so we're at temperature. I'm just going to throw it in this insulation, sandwich it up, put a little weight on there, keep the air out, and I'm just going to leave that be. Next day here, I put this in the rock wool so it would cool as slowly as humanly possible. Now I have no idea how long it took to cool, but this is basically the best I could do. I do want to reiterate that none of what I'm doing is proper heat treating. This is simply the best that I can do at home in my shop without the proper equipment. But now this should be quite soft. It's very soft. So this, I'm willing to say, is properly annealed. That gouged into there, absolutely no problem at all. This is very soft. So now we're gonna harden it. Again, I've done some proper research, some more proper research, and we're gonna harden it. Before it fully cools, we are going to start the tempering process, which is to reheat it to a lesser temperature, and then I'm gonna throw it back in here so that it cools from that temperature as slowly as possible. Now in a perfect world with perfect equipment, you would soak it at that temperature for about an hour. I have simply no way of doing that. So again, this is our backwoods way of heat treating. We're gonna see what happens, and then we'll all know. This is still nice and warm, so I'm going to start tempering here. My heat gun does not go high enough to reach the temperature that I'm supposed to temper this at, according to my research. So failing that, from what I understand, a very light, dull, glowing red is what I'm shooting for. But a very faint glow, not a bright glow, not an obvious glow, just a very faint, dull glow. That's what I'm shooting for now. Basically the first hint of a glow. I'm gonna call that good. I'm gonna throw it back in the rock wool insulation, and I'm gonna let it cool as slowly as possible. I'm calling that a very, very dull, barely perceptible glow. In it goes. I'm going to let it cool slowly and hope that it comes out of there tempered, but still hard. It's the next day now. This has had a chance to cool very slowly. Feels like it's lost an awful lot of its hardness. Maybe we got carried away on the tempering. Yeah. Darn it. Not sure that's going to be hard enough to actually do what we want it to do.
What's our next step?
I think we kind of have no choice but to harden it and just leave it hardened and then carry on with the grinding and just see what happens. We're just trying to get this hard enough that it'll actually cut so we can move on to the grinding phase of this operation. I can already hear the chirping from our metallurgist friends, but again, we are not set up for this. We are doing a backyard hardening job. In the end, we're all going to see how it works or it doesn't work together. After much debate, we've decided that we're just going to go ahead and get the grinding finished on this. It's now super hard, hasn't been tempered. The problem with the tempering is we don't have a way of measuring the temperature or maintaining the temperature. And so we'd just be shooting in the dark again, and a whole nother day would go by. So we're just gonna hope for the best. We're gonna go ahead, put all the cutting edges on this thing, and we're gonna hope it doesn't shatter when we use it. Let's find out.
Yep.
I've got this in my cam relieving fixture, but I have the cam relieving functions locked out right now. I want this just to spin around nice and true, so I can dial this die in here true. And then we'll bring in the cam relieving features and do the actual grinding. We're pretty much set up to start grinding here. I've got my relieving cycles timed to the teeth, so that's where it needs to be. I've got a stop set so that I can't go grinding so far into this die to start hitting the teeth on the back side. So we're basically ready to start going here. You can sort of visualize the clearance being put onto these teeth here because the trailing edge of the tooth is ever so slightly wider than the leading edge of the tooth. And you're seeing it look that way because if you were to run a dial from here to here, say you started here at the cutting edge at 0, that dial would read minus, 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 minus as you made your way to the trailing edge of the tooth, and that is the clearance. Now I'm going to show that in a more definitive way. I'm going to lock out the camming action on this thing. I'm going to put a dial on that lead in, and we're going to see the dial moving as we travel from the leading edge to the trailing edge. Because this is a right-hand cutting tool, we are currently positioned at our leading edge. I have my dial on 0, and as we rotate towards the trailing edge, you can see we get a decent amount of travel on our dial. And that is an actual representation of the clearance that we're putting on this thing. I'm happy with that, so I'm gonna reinitialize the camming action, and we're gonna get back to work, and we're gonna finish this grind up. There's our relief finished, and I've gone deep enough with this grind so that you can clearly see here that it'll be cutting out past the full diameter of what we're going to ask it to cut. So that'll work. This next bit here is purely for aesthetics. I've got my camming action locked out again, so we're just spinning round. I dialed this face, it's within about a half a thou. So we're just going to clean that up, put a nice grind on it. Might make a nice thumbnail. I made this next setup off camera here. The last thing I want to do before we actually try this thing out is I want to clean up the actual face of the cutting edge. So this entire area was caused by plunging an end mill through, and it's pretty jagged, pretty ridgy. I would like to make that one nice smooth ground, finely cut area so that as it interacts with our relief angle, we've got a proper cutting edge there. So to do that, I'm going to use this little mounted point, and I'm going to plunge through and just finish creating that rake angle on the face of the tooth and clean it all up really nice. So there's our leading edge tooth faces. They're all cleaned up. Decently consistent grind on there. I think we're ready to try this thing out. I've decided against putting the slit in this for now. A couple reasons. One reason is I'm inclined to believe that through all the heating and cooling, this has shrunk enough that it may just give us pretty close to perfect fit that we're looking for. The other thing is with the questionable tempering that's gone on here, or non-existent tempering at this point, I think the slit might just be asking for trouble. So we're going to go ahead and try it like this first. Do or die time here, folks. We have our bolt blank mounted up in the lathe. I'm going to follow this die through with my tailstock. That'll help at least keep it square. Now I'm hoping to not hear the telltale crunch of high-speed steel shattering. Got some pretty good looking chips peeling out of there. Gotta say, I'm pretty happy so far. Got a bit of a road to go yet though. Actually cutting quite freely. I'm kind of liking those long continuous chips coming off of there. Really, to anyone complaining about our heat treating, first off, you're right. But second off, it doesn't seem to matter. Well, ladies and gentlemen, we appear to have a thread. Let's back that off of there and get a closer look. Now, will the nut go on? Okay, let's try the nut. Oh, and she goes. And it's not even a gross fit. It's almost decent. That's all I ever expected. That's at least as good as I expected this could possibly be. I'm just super happy with that. Let's do that some more. How fun is that? Double start thread on our nut and now on our bolt as well. Exciting. Well, that's going to do it for this video, guys. Thanks for watching. We'll see you in the next one.